In this video, we're gonna modify the world align nodes so they work in both world space and local space. So let's do it. When using the world align nodes, we have kind of an issue. The texture is projected in world space, so when moving and rotating the assets, it might not work correctly. The most obvious example is when a cube is rotated 45 degrees around all axes. That's what we're gonna fix. You can download the project file of this video on my Patreon. The link is in the description. Let's start with world align texture. Because it's an engine function, I'm not gonna change it. Instead, click here to browse it and press Ctrl C to copy it. Open the folder you want to save the modified version in and press Ctrl V to paste it. Let's add local to its name and add it to the material. I'm gonna use this brick texture from the starter content. Convert it to texture object and connect it. Add a parameter, name it size, set the default value to 100 and connect it to the texture size input. Connect the XYZ output to the base color input and save the material. Create a material instance and assign it to this cube. Right now the material works in world space. We can see it when moving and rotating it. Let's make it work in local space. Double click to open the function. In order to make it work in local space, there are a couple of things we need to do. Here, instead of the absolute world position node, we should use the pre-skinned position node. As you can see, it says local position. That's what's gonna make it work. In order to use it, we should first run it through a vertex interpolator. So let's do that and connect it like this. Down here, instead of the vertex normal node, we should use the pre-skinned normal node. So let's add it, run it through a vertex interpolator and connect it. Save the function. And now the texture is attached to the cube. Right now when we scale the mesh, the texture scales with it. I don't know about you, but I like to have control over the size myself. I mean, I want the position and rotation to be in local space, but the scale, I want to be in world space. So let's fix it. Go back to the function, right click and search for object scale. This function outputs, as the name suggests, the scale of the object. We should multiply it by the pre-skinned local position, so let's do that. And connect them like this. Save the function. And now as you can see, when we scale the mesh, the texture size stays consistent. This is better, especially when we want to place multiple objects with different scales next to each other. Let's give ourselves the ability to toggle between world space and local space. So let's move these nodes here, add a static switch node, connect the absolute world position to the false input and the multiply node to the true input. Add a function input, set the input type to a static bool and name it local space. Enable use preview value and add a static bool here. Connect it to the preview input and connect the function input to the value input on the switch node. Now when the switch is off, it uses the default world align texture, and when it's enabled, it uses the modified local aligned. Connect the switch to here and let's duplicate it down here. Connect the vertex normal to the false input and the vertex interpolator to the true input, and connect the switch node to the input here. Finally, let's connect the function input we created up here to the value input on the switch node, and it's done. Now we can toggle both switches from our material at the same time. Let's save the function and go back to the material. Let's add a static bool parameter, name it local space and connect it to here. Save the material And let's open the material instance. By default, local space is off, so the material works in world space. But when we enable it, now the material works in local space. To make the function more organized, let's add a named reroute right after the local space input we added here. I'll name it local space. Connect it like this. And now connect the named reroute to the switch nodes. That's much better. Next, I'll edit the word align normal function, but before getting to that, make sure to like this video and subscribe to the channel. Also join our communities on Telegram, Discord and Facebook. You can ask questions or answer them, share your work in progress and more. If you're interested in supporting the channel and downloading the project file of this video, check out my Patreon, the links are in the description. This time add the word align normal to the material. Browse it, copy it, and paste it next to the other function. Add local to its name, and add it to the material. Delete this one, duplicate the texture object, and set it to the normal texture. Connect it like this, and connect the size parameter to the texture size input here. Connect it to the normal input, and let's disconnect this one for now. Save the material and open the function. We can use the nodes from the other function to speed up our work. So let's copy these nodes and press Ctrl V to paste them here. Connect the switch node to the input here and delete this one. Down here the input normal is transformed from tangent space to world space. So let's duplicate the transform node and set the destination to local space. Add a static switch. Connect the local space to the true input and the world space to the false input. Add the named reroute and connect it to the value. Then connect the switch node like this. And let's move them over here. The concept is the same as before. If the switch is enabled, the input normal will be in local space, and if the switch is disabled, the input normal will be in world space. Now you may think that we're done and the function is ready, but no, we're not done, and it's not ready. Within this function here, we have another function, word align normals high quality. We should edit this one too. So again, browse it, copy it, and paste it here next to the other ones. Add local to its name, and while the function is selected in the content browser, go back to the function and add it here. Now let's open it. We don't need to do anything new here, just gonna copy some nodes from the previous function. For the word position node, I'm gonna select these nodes, copy them, and paste them here. Connect them like this. And for the word normal, let's copy these nodes, paste them here, and connect them like this. That's all we need to do here. Save the function and close it. Now here in the main normal function, we should add the local space named reroute and connect it to the local space input on the function. This way, when we enable local space in our main material, this function changes too. Now save all the functions and close them. Don't forget to connect the local space static bool to this function too. Save it, and it seems that I forgot to connect the input normal to the new transform vector we duplicated here. So let's connect it, save the function, and let's open the material instance. Drag it here. So let's move it. It's working just fine. but when we rotate it, something is wrong. It turns black. So let's get back in the function and fix it. As I said in the previous video, normals work in tangent space. We transform them into volt space, do the extra math, and transform them back to tangent space. Now in the function, if I zoom here, we can see that we're transforming from volt space to tangent space. But the problem is that when we enable local space in the material, the data that comes into this node is in local space, not volt space. And that's why the effect breaks when we rotate the mesh. So what should we do? It's actually simple. Duplicate the transform node, connect it like this, and set the source on this one to local space. Then add a static switch here, connect the local space to the true input, and the volt space to the false input. And for the value, add the named reroute and connect it like this. Now connect the switch node to the false input here. Now we should do the same with these other ones too. Save the function, and now there's no issue when rotating the mesh. As we saw in this video, the pre-skin nodes can be really useful. That's why they're the topic for the next video, which I'll put up here after uploading it. So click here for more Unreal stuff, and thank you so much for watching. Like this video, subscribe, and join our communities on Telegram, Discord, and Facebook. If you have any questions, leave them in the comment section below. So, see you in the next one.